So today I'm very happy to tell you more about Invision, who we are, and what do we do. So we are a company based in Toronto, and we also have an office in Switzerland, in Lausanne. So we use different sensors like cameras, LiDAR, laser, and we make them collaborate together to extract actionable information from the space where they are deployed without relying on cloud connection and costly hardware. Okay, there's 4 buttons. I pressed the unlucky one.
I can type the other.
How do I use this? Do I have to this every time?
Right,
Okay,
yep.
good. So today, as you know, there are more and more sensors deployed in the public space. You have cameras in train station, in vehicles, in public spaces, and you have a huge need to understand all the visual data that are coming from those sensors. And this is where AI can help. So we differentiate 2 different types of AI. One that we call the conventional AI. The conventional AI use complex neural network. And because of that, it requires to process on the cloud. But as you know, if you have to send through the bandwidth all those images, this is very expensive. Another thing with the cloud is privacy. I'm gonna do. Yeah, I'm gonna use like this. I think because yeah. So as I was saying, one of the issue is privacy, because you never know where your data is stored somewhere in the data center. Second, you can still process locally, but because it's the conventional AI, you will have to invest in costly hardware and local processing. And finally, it's very limited. When you have to scale the solution, it's very limited in terms of insight. So what we have developed at Invision AI is what we call an on-device digital twin. So we have developed an ultra-efficient AI that runs on device on low power, 10 to 15 watts. So this is very important because we don't, for privacy question, all the information stay locally, okay? And second, what we have is a multiple camera system. So if you have a space with about 100 cameras, they all work as one unit. And this you will see later how strong is it. And finally, we understand the space. So we can tell you where in the space an object is. So basically, we can provide the GPS coordinate based on cameras of the object in that space. And on top of that, we can tell you the volume, the speed, etc. So we have 2 verticals. The first one is the rail, and the second one is the road. So we have a collaboration with Thales and Metrolinx that started 2 years ago. So this is what you can see on the video. It's called the forward collision warning system that can detect any obstacles that can potentially cross the tracks, like vehicles or pedestrian. So in that collaboration, Metrolinx is taking care of a LiDAR, and we are taking care of the vision system. What you can see on the top right is this idea that we understand the space. So we can put all the metadata in a 3-dimensional environment. And when you have that information, you can basically count the vehicles or the pedestrian. You can calculate the speed of those vehicles, how far from the train they are, etc. We have a complementary product. It's also a LiDAR and a camera installed on a level crossing. So here the idea is really to understand the level crossing and send an alert to the driver of the train and the drivers. So we can, as you can see on the video, provide GPS coordinates of the vehicles, their speed, their size, and all this metadata, we can also send them to a 2D map that you can see on the top right. And this in real time. On the road side, we have what we call a highway hazard detections. This is one of our largest projects happening today in Greece. So we have about 100 cameras deployed on 32 intersections, and it will detect vehicle that stopped, people that drive in the wrong way, or just pedestrian walking on the highway. And finally, we have the vehicle occupancy detection system, which meant for traffic enforcement. So what we do, we count people in vehicles while the vehicles are driving at a highway speed up to 200 kilometers. This product is at the commercialized stage. So we've been tested by different governments, by Israel, by France, by Canada, and some states in the US. This Yeah, so I will skip quickly to talk about the deployment that we had with Newark Penn Station. So this is just to share with you how a deployment works. We use existing camera. All the footage I send to a computer or a server where everything is processed. Then we send anonymized metadata to a dashboard where the end customer can have access to the heat map, trajectories, and statistics. So this is an example of a project we had with New Jersey Transit at Newark Penn Station. So basically, we perform first 3D dimension, like a point cloud reconstructions. This is for calibration of the camera. This is very important if we want to geolocalize the pedestrian. And then we get those metadata, which is the tracking of the passengers from one area to the other one, from one entrance to the exit. We can also provide some attributes, they wear mask or not, etc. I'll skip that and go directly about what is our goals for the APAC market. So we are looking to collaborate with public-private railroad operators, but also build relationship with system integrators like Thales, Alstom, or ST Engineering. Today we have active project or conversation with HTX, LTA, and ST Engineering. So we have about 3 different opportunities. Two with ST Engineering, one that is starting in September, and another one in Q4. And they are all about passenger flow analysis for train stations. And on the road side, there is an opportunity that is coming for the border security. So there's a tender that will be released soon. And it's about providing some statistics to count people in the vehicles. So that stopped my presentation. Thank you very much.
Great presentation.
Thank you.
So in addition to more than APAC, lots of these you're looking at just starting off in Singapore first. Which other countries are you looking at?
So historically, we started with Asia. Like 4 years ago, our CEO did a similar program as CTA, and we got a project with LGCNS. So we did a 1-year project with them where they tested a single camera to test vehicles and pedestrian. So at that time, it was just a standalone camera. Today, we do multiple camera system, which is something very unique in our industry. So that was our first project in Asia. And one of the reasons we are still looking for Asia is because we believe that rail is more advanced than in North America, where you have more roads. And also you have the infrastructure, you have the most advanced cameras, you have also enough power to process all this neural network, which is not necessarily the case in Europe or in North America.
Looks great. Honestly, great product. Just my 2 cents on the privacy point.
Yes.
On my discussion with customers, if I'm a customer, you would not convince me about the privacy thing just because it sits on your device. Okay? Because it's more difficult to break in a data center, which is like a military, security grade installation, than it would be stealing a device. So I'm sure you're anonymizing the data. I'm sure you're making it safe. I would just say that rather than, we want more privacy because it doesn't go into the cloud.
Yeah.
I don't think it's a relevant point necessarily.
So so the thing that I did not have time to explain is that, remember the scheme, when we send all the streams to the server, we consume the images. So we just consume and extract the metadata. So we don't save the images. So there is no, basically there is no more data. So this may sometimes be a challenge because the operators, they want to click and also see the images. And this is where you have to blur the images, and this is where you have all all the steps how to keep the privacy, and that may be a challenge.
Makes sense. Yeah.
Yeah.
Thank you.
Just one more question. Let's talk internally.
Yeah, of course, yeah. Okay, sounds good. Thank you very much.